Hey guys, in the last video we brought 110 volts into our electronics cabinet, and in this video we're going to begin wiring our Cannon plug for our spindle motor as well as our AVA plugs for our on-off switch, our e-stop, and our tachometer. So let's begin with wiring the spindle Cannon plug, and here's some video on that. Okay, so first, before we start soldering on our connections, I just wanted to kind of point out a couple of things. A soldering iron. I like using a butane type soldering iron. They heat up quick and they work real well. But you can just as easily use an electric soldering iron. They work just fine and do a good job as well. Try to get the right solder for the job. You don't want to use plumbing solder. This is made for electronic circuits. This is rosin core solder, and it's real thin and it works real well. If you try to use the real thick, heavy plumbing type solder, you're going to have problems. So go to the local electronics store and pick you up the right kind of solder. Also, connectors. You can use aviation plugs like I do. I like these. They work real well and they look good and they screw together. It makes a good solid connection. But you can also use DB9 connectors. A lot of people use these. You can get the covers that go on them, and they also work well, but the connections are pretty small and can make soldering difficult. Some people use these crimp type spade connectors. I try to stay away from these if all possible. You have the connection here at the end, and then you also have the connection where you crimp. So just with one connector you have 4 different connections, and that's never good. So I try to solder everything. Also, get you a lighter to heat your heat shrink tubing to go around all your cables. It makes for a nice neat job and works real well. And that's pretty much it. A good set of wire strippers and a small screwdriver, and that's about all you need. So let's get started. We'll wire up these cables. I like to solder these connections, and you can see that the wire will just kind of slides in the hole in the slot, and there's a hole in the back there, and I just stick it in as far as it'll go and then solder it up, and that'll works real well. This is pin 4 at the very bottom here. This is pin 4, the bottom one, the green one. Once it gets hot, it'll just kind of fill up the pin. and then that's secure. Alright, and then the next wire will be our white wire. It's gray in here, but I didn't have, it's hard to show you white, but it'll be terminal 2, which is our white wire. Strip off about a ½ inch or so. Oops. And white wire goes right here. Too much. Cut some of that off. Okay. Okay, there's our white wire. Nice and solid. Our next wire is our red wire. And I don't have a red wire, so I'm going to use a black wire and then put red. I ran out of red wire, so of this gauge. Okay, so the red wire is terminal 3, which is right here. It's a little bit easier if you're young and you can see. There we go. Finally got it going. Okay. Okay. That is our red wire. And then we just need to do our black wire. Okay, so we've got all our wires connected. Alright, so they're connected on this end. We can go ahead and mount this in the box and then wire these up. Okay, so now we're going to wire up my aviation plugs. We've got one 4-pin plug for my tachometer, one for the on-off switch, and this 8-pin for the e-stop and the potentiometer. I have a 2-pin for my home switches, a 4-pin for my stepper motors, on-off switch, and my tachometer, and then this 8-pin for the potentiometer and the e-stop loop. So let's get started and wire this up. Okay, so the first one I'm going to solder up is this the tachometer, and these will be indexed by this little index on the aviation plug. You have to be careful that you don't get this too hot because it will melt through the plastic here. And then the next one will be our yellow wire. Well, let's do the green first. Sometimes it helps to have a little set of needle nose here to get your wires the way you want them. There we go. And the last one is the yellow wire up top. And again, you want to be kind of quick about this, get it hot, and as soon as it starts to go, you don't want to heat it up slow and gradual. You want to get it nice and hot, otherwise you'll melt the pin. That's it. This plug's all soldered up. And ready to go. And so I'll just keep repeating this, and we'll do this one, and then I'll do this 8-pin. This one's going to be a little bit more tricky because we got more to do. Okay, one other thing I forgot to mention, but I think is important, so I thought I would shoot this clip. But one tip, when you're soldering these together, it's easy to get confused. So after you do the plug side, stick the other end in there, and then you can just line up the colored wires. It makes it a lot easier and you don't get so confused. Also, it's a little bit harder to solder this because there's a lot more plastic in your way. And if you're like me and you can't see very well, it makes it even more difficult. But just go around and hit each one, and you're good. Alright, so I'm going to finish these up. Okay, so we finished up our limit switch cabling. We've got our limit switches all soldered and connected, and we've put heat shrink on here. It gives for a nice neat appearance. We have it connected to our cabling. This will be going into our control box electronics cabinet, and then this will plug into this from the outside. And go out to the lathe. I've got two of these, one for the X and one for the Z axis. Okay, so the last aviation plug to wire up will be for our stepper motors. And again, we're using a 4-pin aviation plug, and we're going to have a blue, black, green, and red wire. I'm going to be using this 18 gauge wire. This is twisted copper. And this is actually a 6 conductor, but we're going to fold 2 of them back. It's always good to have some extra conductors just in case you have an issue. This is shielded, and it works real good for the stepper motors. Okay, so the first wire we're going to do here is our green wire, and that is pin 2. And just as we did before, you want to be careful not to get it too hot. You don't want to melt the aviation plug. Then our next wire will be the red wire, which is pin 3. And then our black wire, trim that a little bit, it's a little long. And then last is our blue wire. It's a little long too, let me trim it. There we go. Okay. Got all the wires connected. Now next is the last cabling we need to do, and that is for our stepper motors. We made the cables up earlier. This goes out to the lathe. This will be connected to our, this will be connected inside our control box. And then this is an 8-foot cable going out to the lathe. And we'll just connect it here on the end. Now I'm going to be using 2 different size stepper motors. I'm going to be using a 270 ounce stepper motor. This one's from longsmotors.com. I've used their stepper motors in the past. Haven't had any issues. This is a NEMA 23 270 ounce. And I'm also going to be using a 425 ounce for the Z-axis. Now I have another 425 ounce if I decide to go that route with the X-axis, but I think the 270 is going to be just fine. They're both 3 amp stepper motors. They're both NEMA 23. It's just this one's a 270 ounce versus a 425 ounce. As you can see, there's about an 1.25 inch height difference between the two. And a couple more differences I wanted to point out. This one is an 8mm shaft, and this one is a 6.35mm shaft, or 1/4 inch. Also, this one is a 6-wire. It has the additional yellow and white wire. These are common wires, and we just will not use these wires. We'll just go with the 4 wires. And this one just has the 4 wires. So once we get this stepper motor's wired up, that'll be it, and with the cabling. So what I want to do first is I don't want all this wiring. So what I'm going to do is I'm going to trim it up to about 4 or 5 inches. And then what I want to do is I want to put some heat shrink around there to about here. Actually, let me clip. Since I'm not using these 2 wires, let me clip them back a little bit further, just to keep them out of our way. There we go, like so. We'll shrink this wire, this heat shrink. Just makes for a nice, neat look. I like to do that. Okay, we're going to strip these wires back. About a 1/2 inch or so. And then also on our cabling, I want to first slide some fat heat shrink. This heat shrink is, I'm using a 1/4 inch, and I don't know what the label is on this. I think this was a 1/2 inch or 3/8, probably 1/2 inch. Brown and wire we're not going to be using. This is 6 conductor wire, but I'm only using the 4. It's good to have an extra conductor in there just in case you have any issues down the road. Again, strip about a 1/2 inch back. And I like to just make a T, like so, and then twist the 2. Like so. Alright, let's just do one at a time since she wants to give me trouble. Doesn't take much. And the last wire. And that's it. Alright, so we got it all connected, and what I'll do is, since I didn't have any small heat shrink, so what I'm going to do is just wrap some electrical tape around each one of these, and then we'll bundle it up and heat shrink it. Okay, so you can see I've wrapped each of the conductors in some electrical tape, and that should be good. And then we'll just slide the heat shrink that we put on earlier over the whole wire, slide it all the way up to the motor, and then heat the heat shrink. This butane torch works good. It has this little opening here, and works good for this. Alright, and now you have a completed, and now we completed the cabling for the stepper motor, and that's it. Now we can start wiring up all these connections into the electronics cabinet. So we have our stepper motor cable wired up and ready to go, and that wraps up all of our cabling. So stay tuned for the next video, where we will start installing all this cabling into the electronics cabinet. Thanks for watching, and have a great day.